Now, certainly one of the things that we want to do is we want to use this information to answer questions. We don't just want to do these calculations to do them, even though that's important, but we want to use that information to help us answer or come to some sort of conclusion on certain scenarios. So this particular problem, it says these exam scores. It says an astronomy professor wants to determine if the institution of a revised science program over the past year was effective. At the end of the school year, she randomly selects a sample of 10 final exam scores of students in the current science program and a sample of 10 final exam scores of students in the revised science program. The following is a list of the final exam scores, and you can see we have a list here of the 10 scores from the revised program, and we have a list here of the 10 scores from the current program. So the question says determine the range in standard deviations from each set of scores, and then what can the professor conclude about the revised science programs? So the first thing we'll do is we'll go ahead and we'll find the range. We'll find the range for each set of scores. The range is nothing more than the difference between the extremes, the difference between the smallest data value in a data set and the largest data value in a data set. And we'll go ahead and we will label this as R for range. Now the smallest data value, that looks like this one right here, 55. And the largest data value for this data set, that's 93. So this has a span or a range of 93 minus 55, that's 38. We'll do the same for this data set here, the current program. We have a low end of 37, an extreme of 37, and then a high end over here of 100. So the span 100 minus 37, the range is 63. So you could see that the range, how wide this one is, it's much more wider than this one. This one spans a much greater distance than this one does. In other words, this data seems to be a little more clustered together than this set of data. So we have to keep that in mind. Now for the standard deviations, we'll do that 5-step. The first step is we have to determine if the data is of a population or a sample, because that'll determine whether we divide by the size of the population or we divide by a degree of freedom for a sample. And of course, as we read this, it says right here, at the end of the school year, she randomly selects a sample. So it says it right in the copy here. And for the most part, that's how it should be stated. We have to know how big our sample is. And of course, this is a sample of 10. So we have 10 scores here. And then of course, we have another sample, the current science program, and a sample of 10 of the revised program. So they're each are samples. So these are samples. The second step is we are going to find the mean for each one of these. We know how to determine a mean, add them all up, and divide by how many there are. The mean for this particular program, the revised program, since it's a sample, we label it as X bar, and the mean is 75.4. The mean for this set of data, the current program, again, this is another X bar, and that's a 74.6. So as you look at those means, there's not much difference in the scores. The current program that they're using, on average, a student will score on a final exam of 74.6. They go ahead and they revise the program. They take a sample of 10 final exam scores, and that average is 75.4. So not much difference. So maybe the question is, should they actually institute this new revised program since the average really isn't coming out that much different, right? So then step 3, we go ahead and we have to find the deviations and square them for each set of data. So we'll do that. We'll start with this one. 80 minus the mean of 75.4 then we square it. Back to our calculator. We have our parentheses here. We can type it in exactly as we see it here. 80 minus 75.4. Close off that parenthesis and square it. 21.16. And we're going to do that for each one of the data values for the revised program. And we're going to do that for each one of the values for the current program. Okay, now that we have all those deviations squared, this set right here, this is for our revised program, and this set right here, this is for our current program. So now for step 4, we then sum them all up and divide by n minus 1. So we have 10 for each program, minus 1, so we wind up dividing by 9. So we'll sum all these up. This sums up. We go ahead and add all this up. It comes out to be 1,166.4. We sum all this up. This comes out to be 5,612.4. We divide this by 9. And we'll divide this one by 9. Don't forget, that's n minus 1. That's n minus 1. N is the size of the sample. Subtract 1. 1,166.4 divided by 9. That comes out to be 129.6. This comes out to be 623.6. Then our final step, step 5, is we take the square root of each one. So I'm going to take the square root of this data value, and I'm going to take the square root of this data value. So in our calculator, I'm going to take the square root, 129.6, and it comes out to be approximately, and again, since these are samples, I'm going to make it as S, and that's approximately 11.3842. We'll do the same for this one here. I'm going to take the square root, 623.6, hit enter, and I have a square root. Again, I'm going to label it as S, of approximately 24.972. So as I look at these two standard deviations, this one is less than half the size of this one, or we can say that this one is more than twice the size of this one. So there's a lot more variance going on here, a lot more deviation going on. There's a much bigger difference, a lot more departing going on with this one than with this one. So even though the scores are just about the same, they're less than 1 point off, the cluster of those students is a lot tighter here than it is here. And you can see that the range only goes for 38 here, while here it's a lot broader. So what can the professor conclude about the revised science program? Well, more students, it seems like, are clustering around the average here than this one. It's too spread out here. So it seems as though that the revised program might not necessarily be raising the overall average, but it's making more students closer, much closer to that average. So the program, the revised program, is probably a success.